Okay. So for this job, we have a few different types of cladding. So on the set of plans, we have the James Hardie Prime Line Newport is actually noted on the legend as weatherboard timber look cladding. And then the other cladding that we have on the plans is noted as the James Hardie 6mm Hardie Flex. Now, this is actually going to get changed over to Easy Lap. The reason for this is that we actually have acoustic requirements. This house just falls under a noise area from aeroplanes, so we actually need to go to a higher level of noise category rating for this house. The full set of architecturals details this. So on this house, we're going to a thicker fibre cement cladding option. We're also putting a higher R value, so it's an RW value, which applies to acoustic requirements. So an R value is for thermal insulation, an RW value, which is what this house requires, is an RW50. So that relates to acoustic requirements. So we're going to put extra insulation in the walls and the ceilings. And then we're also going to put a product in between the metal roof sheets called Anti-Con Roof Blanket. So this is a product which has foil in it for a reflective value for thermal, but it also has the glass bats, which helps with acoustic requirements. So that's a system that's actually been checked by our certifier, who's confirmed that they are happy to accept those products to meet the required RW value for this house. So what we're going to do now is we're just going to do the cladding takeoff. So I'm just going to open Bluebeam. I'm going to go File, Open. I'm just going to go into Current Jobs to Brenda Street, Specifications, Colour Selections, and then I'm going to open this set of plans here. This set of plans is our construction issue version. It's got CC at the end, so that's construction copy. So that is our final set of plans. So I'll open that. Now, because I'm actually going to save a copy of this set of plans, I'm actually going to go File, Save As. And I'm just going to go into the estimating area, and I'm just going to add PE at the end for production estimating. So that means that I know that I'm doing this cladding takeoff on the final set of plans for this. So then I'm just going to go to my elevations, and I'm going to set up my scale. So I'm going to do that by going over to a measurement that's shown on the plan. I'm going to click Store Scale in Page and then Calibrate. And then I'm going to type that number in, so 3.24. I usually like the precision to be at 0.01. This just means that it's not going to round up too much. Sometimes I do need a few decimal places. So with cladding, we're actually going to order the cladding in 2 deliveries. So most of our building sites are quite narrow. So when we load our deliveries into the cladding materials cost centre, we're actually going to have 2 delivery notes. So for the lower level, I'm going to use load 1. And then for the upper level, I'm going to use load 2. So at this point in time, we're just going to do our takeoff in 2 stages. So we'll work through the bottom stage, and then we'll work through the upper stage of delivery. This cladding for calculating, we're also going to use the James Hardie product catalogue. So you can go onto the James Hardie website to find out for all the different products specified what the requirements are in terms of the coverage size of the sheet, the length of the board, and also the different options that we have. So just going to go and find the Primeline weatherboard and Newport. So this particular product, the actual board is 4.2 lineal meters long and the width is 170. Now this board actually overlaps the board above it. So the actual effective cover width is 142 millimeters. So I'll just show you what I mean by that. So we'll just go to products and exterior linings. So what we're going to do now is, so that's one product we're going to use. And then we're also going to use the Primeline weatherboard product. So this is the first product that we'll look at. So here's the product specifications, and we can see here that this is the Primeline Newport that we're going to use. So that's where I'm talking about the 4.2, and the width is 170. Now we don't actually use the 170, we're going to use the actual effective cover width, okay? So where we can find that is probably in the installation guide. And this will give us a little bit more information in terms of the actual product itself. So that's all the sheet cladding, Primeline weatherboards. So this is our Newport, which is the profile that we're using. Okay, so here we've got the information here, and there you've got the effective cover, so the 0.142. So it has an overlap, so this is recessed here, so the next board will come and sit on top of that. That's why it has a smaller effective size. Now this is all the Primeline accessories, so this is the other parts of this order that we need to think about when we're actually ordering this product. So for cladding, all of the fixings, and what I mean by that is screws, are supplied by the carpenter. We don't use the starter strip for this product. We will need to order some joint sealant, and these products, the fibre shears and the saw blade, are also supplied by the carpenter. So we're just going to need to allow for some external corners. We have another company that supplies the breathable barrier, and that will already be supplied to the house prior to the carpenters installing the cladding. And again, nails fall into the same area as screws in that it's supplied by our carpenter, so we don't have to worry about that. Okay, so the next thing that we need to look at is the estimating manual. So this is basically, there's lots of different ways of installing different cladding materials. For Newport and Primeline, we're going to follow these instructions. So around the windows, we're going to supply a piece of 42 by 42 timber. To the external corners, we're going to supply a piece of 68 by 42 timber. And then on the internal corners, we're going to use the James Hardie metal internal corner piece that was shown in the previous product catalogue. So this is basically what we're going to be doing. I'll be doing this in front of me and I'll be explaining it in Bluebeam. But I do this so that it's very clear to understand exactly what has been allowed in the different locations. And then this is given to our carpenters on site so that they can see exactly what I've allowed where. When we do this, you have to bear in mind that large sections cut out the boards are not really taken into account. So we won't be able to reuse too many boards. You can see here I've allowed for boards to be used because they're very short distances, but here, even though there's a big window, it's cut into multiple pieces, so that little section in the middle there can't really be reused. Okay, so what we're going to do now is I'm just going to show you this job and show you how I actually work out what materials I need in order to be able to actually work out and mark up the set of plans in front of me for the number of boards that I need for each part of the house. So I'm just having the floor plan open in front of me as well, just so that I can clearly see if there's any returns where I need to allow additional materials. Okay, so now that we've got the scale, we're just going to start calculating the cladding to the lower part of the house here. So what I'd like to know first is the total height that we are going to need to use to calculate the boards. So if I use the length tool here and I just take the measurement from top of slab to the underside of there, so we've got 2.86. Now that's going to be our external wall height. So if you take 2.86, which is the wall height, and we divide it by 0.142, which is the effective cover of the board, you'll get 20.1 boards. So for that part of the house, for each area, we're going to need 21 boards high. You're always going to round up. So for that section there, we're going to need 21 boards high. So then what we want to do is we want to work out from, you can pick a point anywhere, from the side of the house, then we want to measure where do we hit 4.2. Okay? All right, so that's 4.2 there. So in this section, we're going to need 21 boards, okay? So now what I'm going to do is with my plans in front of me that I have printed out, I'm just going to draw a line where the end meets here. So you can just pick a point on the plans and just draw that line across. Then what I'm going to do is I'm going to mark up that there needs 21 boards, okay? Then what we're going to do, so I'll take a picture of what I've done there and I'll pop that in the estimating manual so that that works alongside this. So I'll mark up the Newport cladding in blue. So we're not going to remove that window. It's not a very big window. We're not going to remove the massive one because we're only just using the ends of the boards there. So I'll take a picture of that and you'll be able to see that location. So then what we need to do is we've already got a line along here. So we're cutting the boards off there. So now we need to calculate the number of boards here and the number of boards along the side here. Forget about the piers at the moment. So we're just focusing on this wall to the end here. So this measurement here to here to the end of the wall is 2.7. Okay. So what we're just going to do is we'll just allow full lengths across here. So I'm just going to take the height from the top of this door up to here, which is the same point as before. So that's 0.66 high. We're going to pretend it's just a full length board. We're not going to use the offcuts for that little area. So we've got 0.66 high. Then we'll divide that by 1.42, the width of the board, which gives us 4.6. We're going to round that up to 5, and that is the number of boards that we're going to use for this little area here. Okay, so I'll just take a picture of that and then you can see that I've allowed 5 full complete boards there. Then what we're going to do is we have this tiny little area in here. Now, obviously, we're going to be able to use multiple boards. We don't need a full 4.2 long board to do something which is 0.64 wide. Okay, so what we'll do is we'll go 4.2 divided by 0.6. I'll just round it up to 5. Okay, so we can get about 6 boards from that. So then what we'll do is we'll divide that. So we've got 2 divided by 0.142, and then we can divide that by 6. So we need about 3 boards there. Does that make sense? Okay, so we are always very loose with this in terms of it's just a board. There will be lots of little offcuts that we can't use. So you never want to take this too fine when we're actually ordering for a building site. Otherwise, they won't have enough material left. Okay, so then what I'm going to do is I'm going to allocate, just going to open this other plans here. Now what I'd like to do, there's quite a few piers here for the front. So I think it's probably easiest to just work out how much one of these piers needs and then times it by 3. So if you look at the floor plan for these, we can see that we need about, there isn't actually a measurement from there, I don't think, on the plans that I can see for the width. So we'll just scale that. Yes. Okay. So the 0.57 plus the 0.24, and then we need to go around the back here. So we add 0.57 along the back here and then 0.24 here. So that gives us in total the perimeter of the pier is 1.62. So we've got the pier is, I'll just write this down, 570 plus 240 plus 570 plus 240. So that is 1.62. Now, we'll be pretty loose with this one because of all the cuts and the fact that we're scaling this, it's going to be there's going to be a lot of wastage for a feature like this. So we'll do 0.42 divided by the 1.64. So we're just going to we'll just take it as 2. Then we'll go, I know it's 2.5 when you actually calculate it, but there will be a fair amount of cutting with all of this. Okay, I'm just going to take the size from the top of here, even though there is going to be a piece of timber capping here. I just want to be quite... Okay, so we've got 1.01 divided by the width of the board, which is 0.142. So we need 7 boards high. So we can divide that by 2. So I think we order 4. Sorry, guys, I'm just trying to write this down at the same time so that there's some notes. Okay, so then we've got... Yes. Yep. All of that is, so at the moment I'm just trying to do some little notes on how I'm doing the calculations just so that people can kind of see it on the actual, I'll do a bit of a summary for this video in videos, photos. Okay, so we're happy we've got all of the cladding that we need for that little piece. Then what we're going to do is we're going to do this piece on the left-hand side here. Now, if you read the specifications, which should always be read, we shouldn't exclusively go off the plans. I've just already looked at the specification, so the specification would always overwrite the plan. So you just need to make sure that you are reviewing what the specification has nominated for the cladding. In this particular case, the cladding is the Primeline Newport. We have a variation that has upgraded the fibre cement here to Easy Lap for acoustic requirements. Now this little piece here is a timber fence that will be done in a separate time, and then there's also a little privacy screen here, which if I show you on the floor plan, is like a little screen to screen off this entry from the carport. Okay, so we don't have to worry about that. All we're going to calculate now is this little wall here. Okay, so get the edge there and the edge there. So that's 2.72. Now, I don't think I've actually got a section detail to 100% be able to confirm. I do know that there is, I think this area here is still the same height because there is drop edges through here, but I think the ceiling height is all the same. So that's fine. So we've been able to get that through here, through this section of wall here. On this wall is only 2.64. We're going to do this wall here, which I don't think we can really see particularly well there. So I'll just take it as the higher height here, because we're doing this inside part to the left-hand side that we can't see here. So I'll just take it up to there. So okay, so it is 21 boards again. So that 3.02 divided by the 0.142 of the width of the board. So we have that it needs to be 21 boards. There is going to be a bit of an offcut here, so we can reduce this down. There isn't many openings. There's a little opening here, so obviously you're going to have some of the boards along the side here aren't going to be needed. So instead of ordering the 21, we can just take some boards off of that. So 18 boards will be fine for that section of wall. There's obviously going to be some offcuts. There won't be quite as much needed here. Then what we're going to do is we're going to move around the house. We have these here, which are 600 by 600. I think they're probably going to need to be wrapped on all sides. It's not really drawn particularly well, but they're not going to want to be in their garage looking at the framing on the inside here. So I think if we do, we need to allow for an internal corner here, an external corner here, 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 and here. So it actually makes this feature quite expensive to have it cladded. So we've got 0.6 times 4, so it's 2.4. They're going to be pretty messy. So I think we probably just allow another 21 for those as well. We should be able to use some of the offcuts that we've just made from that window opening and everything here. So I think we just allow 21 here as well. Because they're short runs, so hopefully they can get a bit more efficiency out of those than technically we can get, but we need to allow a lot of timber. So I'm not really calculating them quite as finite as I would with long runs. Because they're such short lengths, we should be able to get a lot of efficiency out of those. Okay, so if you've got 0.6 times 4, so we have, if you actually, so we're going to need to put cladding. I'm just going to colour this in. So we're going to need to put cladding along here, and then we're going to need to put a piece of timber here, and then have cladding along here. Now, if that's all we did, when you're in your carport looking this direction, you're going to see timber framing and it's going to look ugly, which is probably not what the client wants. So we need to allow for cladding here and here. Then we're going to allow for an internal corner here, and then we're going to allow for timber stops here, here. They'll just jam up together, or they might just use one piece. Here and here. So when we take this 0.6, 0.6, 0.6, and 0.6, realistically, it's going to be 2.4 linear meters if we measured it all out. So if you get the 4.2 divided by the 2.4, you're not going to be able to just use those two boards like one board. There's going to be parts missing. Does that make sense? But because it's such a small length, there will be lots of areas on this house along here. All those offcuts we'll be able to use in this area. So we're allowing a reasonable amount, expecting them to be able to use offcuts. If it was a bigger length, if it went all the way down here, I would just work it out and calculate it. But they should have lots of offcuts of 600 to be able to use in that area. Okay, so we are short in that area, but they should be able to use offcuts from this section that we just calculated there. Okay, does that make a little bit of sense? So I don't want to go crazy and allow heaps everywhere, but at the same time, So it's just probably thinking about how they're going to build it on site. All right, so that is that part. Now we'll move to the lower area here. So this has got nice big runs for us. So we've already worked that out. That's fine. I might jump up to this area. So this is going to be easy lap, and just explain a little bit about how we're going to calculate this. So because the rest of the house is very similar to what we've already been calculating. So I'm just going to pull up. So the Easy Lap is a much thicker board than the Hardy Flex sheets that we normally use for cladding. So because it's a thicker board, it has a higher acoustic value, and that's how we can use it for this particular situation. So let me just... Okay. So your normal Hardy Flex sheet is 4.5 millimeters to be used on eaves, so external ceilings. And to be used in this sort of situation, you would use a 6 millimeter board. So when we go up to the Easy Lap panel, that is now an 8.5 millimeter board. So we get an extra 2.5 millimeters of thickness, which is enough to provide us with additional acoustic requirements. Okay, so we're just going to roughly work out, I think these look like they're 900 apart boards, and then they have a timber cover strip. So when we look at the estimating manual, you'll see that the cover strip, we're going to use a 42 by 42 batten, which is what we're using for picture framing our windows as well. So we just need to make sure that we include that. So this product is available. When you look at a 900 millimeter width, it's available in a 3 meter length. So what is our worst case scenario? Okay, so what we might do here is actually work out how much of each board we have left. So usually when I do this, I imagine that this is a big square. So I forget about these corners because they're going to be wasted. So I've got 1.6 there. So we've got 3 meters, take away 1.6. So we've got 1.4 left. So if this height is less than 1.4, which it is, we can use the other half of the board in that location. So what I'll do is I'll just show you what I normally do on here. Usually what I'll do is I will highlight this all in the same color on my set of plans, and then I will mark that this sheet and this sheet are the same. That uses board number 1. Then I move to the next boards, and that board will be number 2. And that board will be number 3, and the one next to it will be number 3. So that's how I normally mark it up, so that the carpenter knows they have to use the offcut of that over here. Okay? So I will just mark that up. I'll use yellow just to keep it consistent with this one. So I'll go 1, 1, 2, 2, 3, 3, and I'll be able to use the third 3 here because we've only used a tiny little piece here. So we've got that isn't even a meter, so we'll definitely be able to use a meter here, half a meter here, half a meter here, and we've still got plenty of board left. Okay, so I'll put a number 3 on this end board here. Okay, so I think that probably covers how you do the actual cladding components. So that's the material. So you just keep moving around the building. It gets easier and easier as you've got longer runs to be able to calculate the rest of that. So what we might move on to is how we calculate the timber battens, and then also how we calculate the accessories for this type of project. So I will add in our Newport. So we're going to have that on the bottom layer and the top layer. So we'll put that as 2, and then I'll update the actual quantities. So here we've got the easy lap, and we were using the 3 meter by 900 because that's the widths. We're going to need some. Now I'm just going to have a look and see which walls this actually goes into to see if we need external corners. So yes, we do. We need internal, and then for the external corners, we're going to use the. So I'll make that 1, and I'll make that. No, that's wrong. 2. 1. Okay, so we've got upstairs, downstairs, upstairs, downstairs. And then for the external area here, it is exactly the same as the FC. So we're going to use the James Hardie internal corner, and then we're going to use the batten for the external corners. So we need the 42 by 42 for our picture frames and our battens, our cover strips for here. And then we need to have the 66 by 42 for our corners. So I'll just drop them in twice so that we have there and there. Okay, so upstairs, downstairs. Now that looks like a mess, so we can click the load sort mode, and this brings up this area. So we can do this cost center, we can sort by load. I don't want to combine like quantities because then I'll lose all my double ups. If we go, that will sort it out nicely for us. So that means this is all your lower delivery and this is all your upper delivery. So we'll work those quantities out in a minute, but I just wanted to show you in terms of the products that we need. Then if you remember from your information, we need to allow, for the Newport, we need to allow the Hardie's sealant. So we normally allow one of these. I don't know if I haven't put a workup in there. I'll find out the actual breakdown. Usually I order one of these per 2 boards. So you can just divide the total quantity of this one and this one in half to generate that quantity. Then what we need to have for the Easy Lap is foam backing tape. So we've got here the foam sealing tape, and we'll need that for upper and lower. So the foam sealing tape is along all sides of this, so we actually need quite a lot. It's in a 25 meter long roll, so that will be fine. We can calculate that based on what I normally do is I take the length of the board. So the total length of the board is 3 meters. plus the board is 900 wide. So I add those two together, which is 3.9. So that's the length of foam you would need to do the two sides of the board. The next piece of foam, which will do this side and this side of the board, will be in the next board's quantity. So that's how I usually work it out. So you've got the number of boards divided by the length of the tape. Okay, so we can get to that in a minute as well. Let me just have a look and see what else we need. So for the Easy Lap, you also need a joiner. So that's used for all the horizontal areas to join the two sheets together. So you can actually use the product codes. We've got all the product codes here. So if you actually look on the installation guide for the products, it will tell you what the product code is for all of the accessories, and you can use that. See how you've got your part numbers? So the part numbers correspond in data build. So if you're not sure, you can just look at the part number and that will tell you which one you need. So they're five, so they've just got two which are the same. So that's for all our horizontal joins. So we're not going to need that one until we go around the building. See here how we've got joins horizontally through here. So if this is a 3-meter board and we have a horizontal join and then another 3-meter board. So that would be the situation when we need the horizontal joiner. We don't need it for these small areas. They're not actually joining two sheets together. We're going to have timber that covers that area. So that's not required there. Oh, why do I keep opening that? Okay, so I think we've got a good number. I'll just sort this again because it's very messy when it's like that. Okay. Now, let's just go to the first one that will calculate how I do all of the 42 by 42. So this is for all of our windows and doors. Now there's a brilliant way on Bluebeam. If you go to the window and door schedule, so what I do is I export the window schedule. So you can go here, export, Excel workbook, page region. So then I just select the window schedule. So this makes it very easy to calculate the heights and widths of all of the windows so that we can we've got all of this. So now we can work out the perimeter of our windows really quickly. So if we go equals bracket that times 2 plus bracket that times 2, we will get the perimeter of our windows. Okay, now that looks horrible and is completely useless. So what we do is we go equals that times, and that gives us it in linear meters. So then what we do is we just drag that down. Then we go equals sum, add all these up. So that gives us our total linear meterage, written really badly. Okay. So then what we need to do is calculate it in lengths, which is that divided by 4.2, which is the length that that particular product comes in. Okay, so it's going to be 24 lengths for the windows. Now, I won't bother. You can order this a little bit if you want to do ground floor and first floor. It's totally up to you. I usually just work out roughly in terms of there's not many windows here, so I'll order a little bit and we'll just need to add on a few extra lengths for all the timber doors. If you export the timber doors, there's so many doors in the timber door schedule that aren't actually external doors. So most of these are all your internal doors. So you just allow a couple of extra lengths for your external doors. So what we'll do here, we need, for this one, we probably need about 15 by 4.2. So that's taking off like 10 lengths for the windows plus 5 for all the doors. Okay. So that's for our windows. Then what we need to do is calculate the number of lengths for these areas here. So we need one, I can't even read that now. Anyway, plus 0.42. Okay, so we need 2 lengths for that one. For the tops of these, I'm actually going to use a bigger piece of timber. So we need 2 lengths of batten. Okay, so we need 4 for the front, 4 for this area. So we've got 1 length there and a bit there, plus all of these uprights. Does that make sense? Okay, then when we're doing these particular ones for all these cover strips, they've actually specified that they want a 42 by 19 and a 1200 wide sheet. So got, doesn't scale very well at all, but that's a 1200 wide sheet. There we go, that works a bit better. So we'll just add go into data build and we will just add in easy lap 1200 by 300, add that in twice, And then we'll also add in the 42 by 19, which is 18 there, but okay. All right. So just show you this area. Really, you're going to be able to count this, not even having to. So we've got 2.7 there, and then 2.62. So both of those are longer than a standard board. I don't think, yeah, we can't really reconfigure that any better than having 300 boards. It's not really going to make any difference. So I think we just split it in half and allow for 3 meter boards, and then they'll have a bit of wastage. It's not really going to work out any better than that, I don't think, in terms of costs. It's just quite a lot of wastage, but there's nothing we can do about that. So with this area here, we can just do a count function. So you're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. So you got 14 boards along the bottom. Happy with that? Yeah, so you've got a couple of options with this particular product. You can actually buy it in for that 1200 width. So in the 900 width at the front of the house, we only were able to buy in 3 meter long sheets. When we go to a 1200 wide board, like we've got in this particular situation here, we've got 3 options for length. So we can go to 2.44, 3 meters, or 3.6. So that's what I was kind of mucking around with in terms of these lengths. But if we go to a 3.6, it still leaves 2 there. So I don't know. It just seems pretty messy. So I'll just go 3 meters, and then they can change where they want this length to go. See, even this dimension here where they've drawn the line, I'm not quite sure why they've drawn it there, is over 3 meters. I don't really want to buy 3.6 boards because all of this area here, I don't know, it's just a bit confusing how it's been drawn. So I'll just draw it here, and then we'll put the timber batten along here. So I'm going to ignore that line there and just do a batten along this length here. Okay, so that's what we'll work out. That one now is 10.8 divided by 5.4. Easy. So 2 lengths there, and then we'll just need cover strips on all the corners here. So normally what I do, I use it in the same logic as we had before, is if we allow length here and here, we don't need anything on the bottom. The next sheet will cover there and there and there and there. So normally what I just do, which allows us plenty of wastage because you're probably only going to need one on the bottom here, we're going to use a different product where this board meets the eave sheet out here. So if you just allow for that one 3 plus 1.2, if you allow 4.2, so basically I'd probably just allow pretty much a length of timber per board here. So we've got our 14 boards here. So if I go to where we've got the easy lap here, so if I allow 14 there, I'll probably just allow 14 at 5.4. That's plenty of wastage. That's going to be heaps for the guys to be able to use, yeah? Happy with that logic? Okay. So you're saying if this length here was 2.4? Yeah, so if you had on we'll redo this house. So if this was 2.4 here and then downstairs was 2.4, 2.4, then you can just order 2.4 length sheets because you're going to have 2.44, so that's going to give you, so they'll just trim the top. So you can configure it however you need. For here, well, you just break it into sections. So here you've got a different elevation here, so that's fine. I would just allow the same. You're going to use a lot of timber on this job. It's got a lot of corners and different openings. Yeah, like Mike said, a lot of wastage. I wouldn't be too lean. I'm always too lean, and you can see how generous I am with this sort of stuff. Depends who we've got working on the project. Some of our carpenters are very efficient with material wastage and some are not. You'll also notice when we actually talk about if I was actually going to be incredibly detailed, if you started to work out timber lengths for windows and things like that, you have to take into account. So maybe this window, see how it's 5.7, but probably when we did like a quick calculation, you just go, okay, well, I'll just order 5.7 and then so that's one length at 5.4 and then I can use the 300 here. Well, realistically, a carpenter is not going to use a tiny little piece of timber there. It's just going to go in the bin. So, you know, your extra little bits and pieces aren't going to get used up. They're going to go in the bin. So I just try and think a little bit about how they're actually going to use the materials on site. It is a big deal if they're too short on things like particularly corners, because what they do is they actually install the corner and then butt the timber up against it. So if they don't have that corner there, they stop work on all of this cladding because they can't finish it. So if we order this material on every single job, it's not really a big deal if we have a little bit of foam sealing tape or a couple of lengths of this timber. We'll just take it around the corner to another job. Okay? So I wouldn't worry about being a little bit over. That's not really a big deal. Some of this material is really quite cheap. So if you're a couple of lengths over on this, look, it's $15, $20. If I'm short a couple of lengths of that and the guys can't finish the cladding, I could maybe have to send them away wait a week till they can come back to site, I've got a $50 delivery fee, and then I also have to pay them $200 to come back to site to finish it because it's an extra call out. So that's how it works in practicality. So if ever you think a house like this has got a lot of windows, a lot of corners, so we've got returns in here, we've got lots of timber work on these sections, we've got a lot of timber work on these gables, it's okay. Just, like, don't go crazy, but if you've worked it out and you've rounded up, totally fine. I'm really happy with that sort of result. I think that means that we're not going to cut it too fine. It's really easy as an estimator to calculate it out, but not think about how it's actually going to get used on site. So if we're a little bit over, all of these products are used day in, day out by this company. We can send them back to the supplier for a credit as well. Okay? So no biggie. All right. So I think, are you guys happy with that logic? Would you be able to apply that to the rest of the house, do you think, or do you want me to keep going? Okay. I'll just talk about the top of these. So this product here, I will probably just allow, let me just find it. We use a product for our garage door jam, so I'll probably just use that. That's something we use fairly regularly that we've got a price for. Here we go, the 140 by 30 garage door jam. So we'll probably just order, I think probably, we've actually got to fill in a bit. I'll allow one per post because we're actually going to have to fill in, we're going to have to cut around all of this and then fill in this area here. So I'll order one per post. Here we go. So we'll do 3 at 5.4 to top of cladded piers. So that covers us for that area, and I'll do that on load 1 so that goes out initially. And we just keep working around the house. So it gets easier as we go around some of the big runs when we're doing okay, so I'll just mark where that line runs, which is pretty much in line with that window. And then we just keep going round. And again, I wouldn't worry about, there's a tiny little bit here, but we won't worry about that. We'll fill that gap in a second because we'll need full lengths there and then little pieces here. So I'll just move round to do this part. And then again, I'll just allow full lengths there. So what I'll actually allow, this part here can fill in this section here, easy. So we'll do those 2 parts. I'll just connect to 21 lengths. So what I actually mark when I'm doing the plans is I'll actually draw a line to there and to there and just do 21 boards. So that's how I'll show that the waste from this one can be used over this side, and then that covers the next section, and then we can probably just we've still probably got enough space there. So that was there to there. Yeah, so we've still got enough to use there as well. So I'll do a line connecting that piece, and that covers us for all of those sections. Okay. Does that help confirm, like, does that kind of cover some of the questions that you had about how to do the cladding? Still got questions? You keep asking me. I'm just going to keep working on this, so I have to finish it eventually. So you can go for it. You're good. Okay, so for now, uh, that's okay. And like, I just wanted to go through this one because we've made some changes and we've got some acoustic requirements. So this is a little bit different, and this is what you just need to sort of have a look at when you're reviewing plans. It's really important to look at your specifications and just see what's noted in any of the special notes. So we've got the external walls are RW50. You've got the wall and ceiling and roof insulation, and then you've also got the acoustic rating for RW30. So by checking your specification and your PCV variations, so that's your post-contract variations, you will start to work out whether the plans are correct. Now, we wouldn't always update the plans. We're not going to update the plans for something like this cladding because I'm actually ordering the same. It looks the same as this. We're just using a slightly thicker board. So I've just provided that when we were advised of that change, this Newport complies because of the thickness of the actual boards themselves. And then you'll also find that we're able to use the Hardy Flex and the Easy Lap in the same board sizes. So it's not necessary to update the plans with that sort of information. So that is sort of how you'd keep working through those ones. So I will end the video there just due to the fact that otherwise it will run too long and take too long to upload. But I'll finish this takeoff and I'll put all the pictures of all the different sections in the estimating manual, and then I'll put the video online so you can have a little look at it.